Okay, so we kind of had the project selection example in the last video, and we're now going to add a few constraints to this. And I'll kind of model the constraints normally, and then I will kind of do it how the book does it. So recall, we have project selections. Each project has a profit, and we're trying to maximize that profit. But each project also has some cash requirements and personnel requirements, what we call resource constraints, and they have to be less than the available resources. And we have some additional restrictions here. One is that if we have project 1, then we also need to have project 4. And in reality, that just means that project 4 needs to be greater or equal to project 1. Here we look, I just kind of copied this logical constraints from the book. Not the other way around. So, we can have a situation where we have project 4 but not project 1, but we can't have a situation where we have project 1 and not project 4, which means that project 4 must be greater or equal to project 1. And the second constraint is that at least one of projects 1 and 3, maybe they were similar projects, or maybe they required one very specialized employee, I don't know. But the idea here is that basically project 1 plus project 3 has got to be less than or equal to 1. So let's solve this with Solver. So let's just build the model we built last time. So we're trying to maximize our total return, subject to by changing these guys, our binary projects assignments, subject to the constraints that our resources are less than or equal to the available resources. And we actually had one additional constraint in that all of our decision variables need to be binary. Okay, and we're going to use the simplex. Let's just solve this. And we don't change, and this is because I copied the solution from the last example. And we're going to model our constraints down here. So what we're trying to say here is that if project 1 then project 4, basically project 4 is greater or equal to project 1. So we can rewrite that as project 4 minus project 1 is greater or equal to 0. And this is what's happening here. We have E11, which is project 4, B11, that's project 1, is greater or equal to 0. So this is the top line in this box of logical conditions. Now, the next one, at most one of A and B. So at most one of projects 1 and 3. And here we have project 1 plus project 3 is less than or equal to 1. Very, very simple. Kind of logical is that you just you can only have one of them, so you can't have both of them. So adding them together, you cannot have two. Okay, so let's add these to the solver. And we add the constraints. And our logical constraint for our first one is that this is greater or equal to 0. And you see, because we have project 1 per project, not project 4, this is violated at the moment. So we're going to have some change. And then we're going to have the next one. We're going to add and in this case, the projects added together. And again, we violate this constraint again because we have project 1 and project 3, so they're equal to 2 at the moment, is less than or equal to 1. Let's click OK, and let's get the answer report. And you see here, we make a little bit less profit this time because we can't get the optimal solution that we had before. But here we have projects 1, 2, 3, 4, and 5. Which gives us a maximum of 490 down from, I think, what was it before? Down from 530. We've got our available resources, 134,000 for cash and 10 for personnel. And then we bind on this constraint as we have one of projects 1 and 3. Funnily enough, we don't bind on the constraint above because we actually have project 4, but not project 1. And you can see here, the only one constraint bound at the moment is at most one of projects 1 and 3. The cash used is less, 134,000 is less than the bind. We've got a slack of 16,000. And the personnel used, it's 10, but we had 12 available, so we have a slack of 2. Okay, so that was just adding some simple logical constraints. And I guess if you're doing this, it does make sense to do this kind of section where, just to make it consistent, you have all your kind of calculated variables here, and then you have your signs, and then you have the the constraining number there on the right. Okay, there we go. And that was just very simply adding some logical constraints.